Welcome to Most Reliable Inline-6 Engines. We break down the most legendary, durable, and high-performance straight-six engines ever built. If you love reliability and power, you're in the right place. Subscribe, and let's dive in. AMC Inline-6 Technical Analysis. The AMC Inline-6 engine represents a pinnacle of American automotive engineering, characterized by exceptional durability and straightforward mechanical design. Produced from 1964 to 2006, this engine family spans multiple displacements, including 232, 258, and the renowned 4.0-liter variant. The engine's architecture features a robust cast iron block with 7 main bearings, providing superior crankshaft support and minimizing potential structural failures. Cylinder bore dimensions typically range from 3.75 to 4.0 inches, with stroke lengths between 3.2 and 3.98 inches. The cylinder head utilizes a 2-valve per cylinder pushrod design, employing hydraulic lifters that eliminate manual valve adjustment requirements. Compression ratios consistently hover between 8.5 to 1 and 9.0 to 1, balancing performance with fuel efficiency. Peak horsepower for the 4.0-liter variant reaches approximately 190 horsepower at 4,600 RPM, with torque figures around 235 pounds-feet of torque at 3,200 RPM. Crankshaft construction involves forged steel with 8 counterweights, enhancing rotational stability and reducing harmonic vibrations. Connecting rods measure 6.125 inches, fabricated from forged steel to withstand significant mechanical stress. The engine's oiling system incorporates a 6-quart capacity with full-flow filtration, maintaining oil pressure between 40 to 60 psi at operating temperature. Cooling system design ensures consistent thermal management through a 13-quart capacity and strategically positioned water passages. Fuel delivery evolved from carburation to Renix electronic fuel injection, 1987 to 1990, and subsequently to Chrysler's multi-point injection MPI system. Documented reliability metrics demonstrate consistent performance beyond 300,000 miles with routine maintenance. Common service intervals include timing chain replacement at 180,000 miles, valve cover gasket service at 100,000 miles, and potential head gasket replacement approaching 200,000 miles. The engine's thermal efficiency and mechanical simplicity contributed to its legendary status in Jeep vehicles, particularly the Wrangler and Cherokee models. Manufacturing tolerances remain consistently tight throughout production, with minimal variation between production years. Cylinder wall wear rates average less than 0.001 inches per 100,000 miles, indicating exceptional material quality and engineering precision. The Ford 300 Inline-6 engine represents a quintessential American workhorse, engineered for durability and consistent performance across diverse applications. Introduced in 1965 and produced until 1996, this engine family became synonymous with reliability in Ford's truck and commercial vehicle platforms. The engine's fundamental architecture centers on a cast iron block with 7 main bearings, providing exceptional crankshaft support and minimizing potential structural failures. Displacement measures 300 cubic inches, 4.9 liters, with bore dimensions of 4.00 inches and a stroke of 3.98 inches. Cylinder head design employs a 2-valve per cylinder configuration with hydraulic lifters, eliminating manual valve adjustment requirements. Compression ratios typically range between 8.5 to 1 and 9.0 to 1, balancing performance with fuel efficiency. Power output evolved throughout its production, initially generating approximately 114 horsepower, increasing to roughly 122 horsepower in the early 1980s before fuel injection implementation. Torque characteristics remain exceptional, peaking around 260 pounds-feet of torque at relatively low RPM ranges. Crankshaft construction utilizes forged steel with 8 counterweights, enhancing rotational stability and reducing harmonic vibrations. Connecting rods measure 6.125 inches, fabricated from robust forged steel to withstand significant mechanical stress. The oiling system incorporates a 5-quart capacity with full-flow filtration, maintaining oil pressure between 45 to 50 psi at operating temperature. Cooling system design ensures consistent thermal management through strategic water passage routing. Fuel delivery systems transition from carburation to electronic fuel injection, improving overall efficiency and performance. Documented reliability metrics demonstrate consistent performance beyond 300,000 miles with routine maintenance. Typical service intervals include distributor gear replacement at 150,000 miles and water pump service at 100,000 miles. The engine found widespread application in Ford F-Series trucks, Broncos, and various industrial equipment, cementing its reputation for dependability. Manufacturing tolerances remain consistently precise, with minimal variation between production years. Cylinder wall wear rates average less than 0.0008 inches per 100,000 miles, indicating exceptional material quality and engineering precision. The BMW M30 Inline-6 engine represents German engineering excellence, serving as BMW's flagship power plant from 1968 to 1994. The engine architecture features a cast iron block with 7 main bearings and an aluminum cylinder head, establishing the template for future BMW straight-six designs. Displacement variants range from 2.5 liters to 3.5 liters, with the most renowned being the 3.5-liter configuration, producing 215 horsepower and 230 pounds-feet of torque in standard form. Bore dimensions measure 92 millimeters, with varying stroke lengths from 75 millimeters to 86 millimeters, depending on displacement. The cylinder head employs a single overhead camshaft, SOHC design with 2 valves per cylinder, featuring hydraulic valve adjusters in later variants. Compression ratios vary between 8.0 to 1 and 9.0 to 1, optimized for period fuel quality. Crankshaft construction utilizes forged steel with 12 counterweights, ensuring exceptional rotational balance and durability. Connecting rods measure 143 millimeters, manufactured from forged steel with traditional split-cap design. The oiling system incorporates a 6.5-liter capacity with full-flow filtration, maintaining pressure between 3.5 and 4.5 bar at operating temperature. Cooling system design features precise coolant flow management through strategically positioned passages, with total capacity varying between 9 to 11 liters. Fuel delivery evolved from Bosch Elgetronic to Medtronic injection systems, improving efficiency and power delivery. Documented longevity regularly exceeds 300,000 kilometers with proper maintenance. Critical service intervals include timing chain replacement at 160,000 kilometers, valve adjustments every 30,000 kilometers for non-hydraulic variants, and typical oil service intervals of 7,500 kilometers. Manufacturing tolerances remained exceptionally tight throughout production, with cylinder bore roundness typically maintaining 0.007 millimeter tolerance. The Mercedes-Benz M103 Inline-6 engine epitomizes Stuttgart's commitment to engineering excellence, produced from 1984 to 1995. The engine's fundamental architecture comprises a cast iron block with aluminum cylinder head, featuring 7 main bearings for optimal crankshaft support. Displacement options include 2.6 liters and 3.0 liters variants, with the 3.0-liter version producing 177 horsepower and 188 pounds-feet of torque in standard configuration. Bore dimensions measure 88.5 millimeters, with stroke lengths of 80.2 millimeters, 2.6 liters, and 92.4 millimeters, 3.0 liters. The single overhead camshaft SOHC cylinder head design incorporates 2 valves per cylinder with hydraulic lifters, ensuring maintenance-free valve clearance adjustment. Compression ratios maintain 9.2 to 1 across most variants, optimized for premium fuel requirements. The crankshaft features forged steel construction with 8 counterweights, delivering exceptional rotational balance. Connecting rods measure 147 millimeters, manufactured from forged steel with crack cap technology for precise reassembly. The oiling system features a 7.5-liter capacity with integrated oil cooler, maintaining pressure between 3.0 and 4.0 bar at operating temperature. Cooling system design incorporates precise flow management with total capacity of 11 liters. Fuel delivery utilizes Bosch KE Jetronic mechanical-electronic injection, providing reliable performance with minimal complexity. Documented reliability shows consistent operation beyond 500,000 kilometers with proper maintenance. Service intervals include timing chain replacement at 200,000 kilometers, valve cover gasket service at 120,000 kilometers, and regular oil changes at 10,000 kilometer intervals. Manufacturing precision remained consistent throughout production, with cylinder bore tolerances maintaining 0.06 millimeter specifications. The greatest inline-6, the Nissan RB 26D ETT, represents Japanese engineering prowess at its zenith, serving as the power plant for the legendary Skyline GTR from 1989 to 2002. This twin-turbocharged inline-6 engine features a cast-iron block with 6-bolt main caps and an aluminum cylinder head. Displacement measures 2.6 liters with bore and stroke dimensions of 86 millimeters by 73.7 millimeters, optimized for high RPM performance. The dual overhead camshaft DOHC cylinder head design incorporates 4 valves per cylinder with solid lifters, enabling operation up to 8,000 RPM. Stock compression ratio maintains 8.5 to 1, balanced for forced induction. The engine employs parallel twin Garrett T28 type turbochargers, each feeding 3 cylinders with maximum boost pressure limited to 10 PS in factory specification. Power output rates at 276 horsepower due to Japanese regulations, though actual output measures closer to 316 horsepower in R34 specification. Crankshaft construction features forged steel with counterweights designed for high RPM stability. Connecting rods measure 121.25 millimeters, manufactured from forged steel with secure fastening systems. The oiling system incorporates a 5-liter capacity with multi-pathway lubrication, maintaining pressure between 4.0 and 5.0 bar at operating temperature. Cooling system design features separate water-cooled turbocharger housings and oil cooler integration. Fuel delivery employs 6 individual throttle bodies with sequential multi-point injection. Documented modifications regularly achieve 600-plus horsepower, with supporting modifications while maintaining reliability. Critical maintenance includes timing belt service at 60,000 kilometers, coil pack replacement at 80,000 kilometers, and turbocharger inspection every 100,000 kilometers. Manufacturing tolerances remained exceptionally precise throughout production, with cylinder bore deviation typically less than 0.005 millimeters. The Toyota 2JZ represents the pinnacle of Japanese over-engineering, produced from 1991 to 2002. The engine's architecture features a cast-iron block with 7 main caps and an aluminum DOHC cylinder head. Displacement measures 2,997 cubic centimeters, 3.0 liters, with bore x stroke dimensions of 86 millimeters x 86 millimeters, creating a square design optimal for both power and torque production. The closed deck block design provides exceptional cylinder stability under high boost conditions. Factory specifications rate output at 326 horsepower at 5,600 RPM and 332 pounds-feet of torque at 4,000 RPM in latest iteration. Compression ratio maintains 8.5 to 1, perfectly balanced for forced induction applications. The sequential twin-turbo system employs 2 CT20A turbochargers with air-to-air intercooling. Cylinder head design incorporates 4 valves per cylinder with bucket overshim valve actuation, allowing precise valve control up to 7,200 RPM. Crankshaft construction features forged chromoly steel with 12 counterweights, supporting extreme power applications. Connecting rods measure 144 millimeters, manufactured from forged steel with large end caps secured by grade 11 bolts. The oiling system includes a 5.8-liter capacity with multi-stage pressure relief, maintaining 43 to 63 psi at operating temperature. Cooling system design incorporates dual air bleeds and integrated oil cooler passages. Fuel delivery utilizes sequential electronic injection with 6 550cc injectors. Documented reliability shows engines regularly achieving 800-plus horsepower on stock internals with appropriate tuning. Service intervals include timing belt replacement at 60,000 miles, valve clearance inspection at 80,000 miles, and spark plug replacement at 60,000 miles. Manufacturing tolerances demonstrate exceptional consistency, with cylinder bore variation typically under 0.004 millimeters. The BMW N52 Inline-6 engine represents BMW's last naturally aspirated six-cylinder power plant, produced from 2004 to 2015. Engine construction features a unique magnesium-aluminum composite block with aluminum cylinder liners and aluminum cylinder head. Displacement varies between 2.5 liters and 3.0 liters, with the most powerful variant producing 231 horsepower at 6,500 RPM and 199 pounds-feet of torque at 2,750 RPM. Borex stroke dimensions measure 85 millimeters x 88 millimeters in 3.0-liter configuration. The cylinder head employs BMW's Valvetronic variable valve lift system and double Vanos variable valve timing, eliminating traditional throttle bodies for improved efficiency. Compression ratio maintains 10.7 to 1, optimized for premium fuel. The engine incorporates electric water pump technology, reducing parasitic losses and improving thermal management. Crankshaft construction utilizes forged steel with asymmetric counterweights for improved NVH characteristics. Connecting rods measure 145 millimeters, manufactured from forged steel with cracked cap technology. The oiling system features a 6.5-liter capacity with integrated oil-water heat exchanger, maintaining pressure between 2.5 and 4.5 bar at operating temperature. Cooling system design includes precise electronic control through the electric water pump, with total capacity of 10 liters. Fuel delivery employs direct injection with piezo injectors, enabling multiple injection events per cycle. Documented reliability shows consistent operation beyond 200,000 miles with proper maintenance. Service intervals include Vanos solenoid cleaning at 100,000 miles, valve cover gasket replacement at 80,000 miles, and electric water pump replacement at 70,000 miles. Manufacturing precision maintains tight tolerances throughout production run, with cylinder bore variation typically under 0.06 millimeters. The BMW B58/S58 engine family represents BMW's latest turbocharged inline-6 architecture, introduced in 2015 and continuing current production. The closed-deck engine block utilizes aluminum construction with wire arc sprayed cylinder liners, paired with an aluminum cylinder head. Base B58 displacement measures 2,998 cubic centimeters with Borex stroke dimensions of 82 millimeters x 94.6 millimeters, while the S58 performance variant maintains identical displacement with modified internals. Power output ranges from 335 horsepower in standard B58 configuration to 375 horsepower in latest iterations, with the S58 variant producing up to 503 horsepower in competition specification. The cylinder head employs BMW's latest Valvetronic 3-variable valve lift and double Vanos variable timing systems. Compression ratio varies between 10.2 to 1 for B58 and 9.3 to 1 for S58, optimized for respective boost levels. Turbocharging system utilizes single twin-scroll turbocharger in B58, while S58 employs dual monoscroll turbochargers. Crankshaft features forged steel construction with integrated counterweights, friction optimized through plasma transfer wire arc coating. Connecting rods measure 145.5 millimeters, utilizing forged steel with advanced surface treatments. The oiling system incorporates an 8.0-liter capacity with integrated oil-water heat exchanger, maintaining pressure between 2.0 and 5.0 bar, depending on operating conditions. Cooling system design features electric water pump technology with map-controlled thermostat. Fuel delivery employs direct injection operating at 350 bar pressure, enabling precise mixture formation. Documented durability shows engines maintaining integrity beyond 150,000 miles with proper maintenance. Service intervals include spark plug replacement at 45,000 miles, ignition coil replacement at 60,000 miles, and oil service based on vehicle-specific algorithms. Manufacturing tolerances demonstrate exceptional precision, with cylinder bore variation typically maintaining 0.005 millimeter specification. And that's a wrap. If you enjoyed this video, don't forget to hit that like button and subscribe for more content. Let me know your thoughts in the comments below, and if you want to stay updated, turn on the notification bell. Thanks for watching, and I'll see you in the next one.